Welcome to the Swine Health Black Belt Podcast, the latest swine health research digested for you. My name is Dr. Clayton Johnson, and I'm your host for today's episode. Joining me in the podcast studios is Dr. Elisa Crisci. Dr. Crisci is a viral immunologist and assistant professor at the Veterinary College of North Carolina State University. Dr. Crisci, welcome to the podcast. Please introduce yourself for the audience.
Hi, nice to be here. Thank you for the invitation. Yes, so as you said, I'm assistant professor at the Veterinary College at NC State. I have joined this position in 2018, so it's almost about 5 years that I'm working in the college. I'm a veterinarian. I got my master and Ph.D. in Europe, and my main interest is viruses, immunity, and the pig, of course. The pig has been my main animal in the last 15 years, not just as a relevant food animal, but also as a biomedical model for humans. So as I've been working in all these years here at NC State in different pig viruses, in immunity, in particular innate immunity, and testing, eventually vaccines or developing new drugs or compounds that are actually active against viruses.
Well, we could certainly use some new drugs or compounds that are active against viruses. Respiratory disease in particular is a big problem for pig producers all over the world. Would any of your new compounds have opportunities to work against respiratory disease?
Well, yes, actually, my main viruses are respiratory viruses. So I've been working almost 5 years now with PRRSV, that is the acronym for porcine reproductive and respiratory syndrome virus. And on the other side, another virus has been working almost all my career is influenza virus, both swine and human influenza. And both are RNA viruses, so very high rate of mutation. It's difficult to have an effective vaccines that work against all the strains. And that's why we are trying to develop some complementary approach that can, have some effect on those viruses, in particularly related to respiratory complex. So we recently have studied an antiviral that we call BioPly. That is, the name is coming from the bioactive component of the compound that is a derived from platelet. So it's actually a new class of biologic that we have been developing, and we have done that from horses, swine, of course, and dogs, humans. So that compound can actually have different sources, but is mainly, of course, blood is the main sources because where platelets are located. So we have been able to isolate a specific compound that has a lysate form from blood and contain this what we call host defense peptide. And we knew from the beginning, so this compound was already tested in bacteria layout, so had some antibacterial activity. It was tested mainly in horses. And so one day we decided, okay, let's see if this compound has any antiviral activity. So actually, we just published last month in Viruses a publication where we tested the antiviral capacity of this compound in vitro. And we found that it's actually active against PRRS, flu, and what we call a prototype coronavirus that is not COVID, but is a virus of the typical cold that we use as a prototype. And so we describe antiviral capacity in vitro using primary cells that we isolate from the lung. So in particular, alveolar macrophages and pulmonary intravascular macrophages that we get from healthy pigs. So we were able to demonstrate the antiviral capacity, but also we could see some immunomodulatory capacity in terms of being able to modulate macrophage function. So that's been also a very interesting outcome too. So it's not just an antiviral, and was just already before antibacterial, but we know now that has some immunomodulatory capacity too. So that was very interesting.
I was taught in veterinary school something I'll never forget, that my job as a veterinarian is to keep the animal's body alive long enough to heal itself. And so I think that's wonderful that it not only has a direct antiviral and antibacterial effect, but it also modulates the immune response to help improve the body's response to the pathogen, because ultimately that's probably the most important response. Do we know much about the mechanism of action? Does the compound work similarly on viruses the same way it does on bacteria? Are they two totally separate, or we don't know yet?
So we know that has an effect on biofilm. We do not have of bacteria biofilm. We do not exactly how that interaction happen. And for what I can tell about the antiviral, that has been the work we have been doing, because the antibacterial has been done by my collaborator. So for the antiviral, it seems like not related in changing, for example, cytokine production in the cell. So we are speculating that might be some direct interaction between the virus itself and the compound. Could be on binding sites, or other type of interaction that we do not know at the moment. We will evaluate that kind of mechanism, but we do not have actually a clear mechanism that we can tell, yes, this is the way how it works. Also because it's still a raw compound that is a mix of different peptides. So we do not have one peptide that we know it might be the relevant one. So we still have to figure it out, also that portion of the compound itself.
Can this compound be found in the platelets of any species, or is it specific species of animals that their platelets produce this compound and therefore they're the only ones who we can get the compound from?
No, actually, it's pretty not species specific. As I said, we were able to isolate that kind of compound with a specific methodology that allows only to have a lysate, so do not have any cellular component in the compound, from dog, pig, cattle, horses, and human. So it's not just one species, it's a general. So those peptides are present in the platelet, in just because they are platelet and they have certain function in the body. So I believe if we try to isolate from lemurs, we probably be able to. It will depend, of course, of the access to blood of animal, and of course we use at the beginning food animal just because it was easier, and also because of the interest my collaborator had, for example, in horses, and my interest in pigs. So other people have tried from dogs too, because they are interested in other dog type of diseases. So it's really depending on for what purpose you're using it. So what is the target of that, how you want to use the compound, and in which kind of disease or in which kind of illness in that animal.
Is there a pathway for an antiviral approval process for commercialization, or that pathway doesn't really exist and an antibacterial approval process would be much more appropriate because this would be easier to commercialize the product through that approval process?
So there is a patent on this, and actually there's a startup that has been created based on this compound. It's called Kenteros Inch. So they have the intellectual property, and is actually already including all these different effects in antiviral, antibacterial, and potential immunomodulation. So there is actually a path towards commercialization through this startup. We are moving forward to have more validation and efficacy trial that we can use to a potential future commercialization. So there is something going on in that portion. It's just still at the beginning.
Very good. Well, thank you on your work on that. And thanks for coming on the show, Dr. Crisci. To our audience, thank you for listening to the Swine Health Black Belt podcast. Please visit us at swinehealthblackbelt.com if you haven't been to our website. And if you haven't subscribed to the podcast, please do subscribe. You'll hear messages like our excellent information on the novel antiviral and antibacterial compounds that Dr. Crisci is working on all of our future editions. Thank you very much, Dr. Crisci. It's been a pleasure to chat with you today. Really appreciate you making time in your schedule to come see us. To our audience, thank you for listening in. We'll see you next week. Have a great rest of your day.
Hey, everyone. We're always searching for the latest and greatest research to share each week. If you have a swine health-related research trial and would like to come on the show to talk about it with me and share it with our audience, feel free to send an email to healthblackbelt@swineit.com, and we would love to take a look at your research.